All right. Well, without further ado, we've got David Bates coming to speak with us today on the Code to Magic, building things that blink, talk, and occasionally catch on fire, which is always good. Right? No, you're pushing the boundaries. David is the Director of Innovation at Osmo, where he shapes the company's technical vision and guides the development of innovative solutions to solve complex challenges. Partnering with customers and industry leaders, he ensures that Osmo stays at the forefront of technology advancements by tailoring solutions to meet unique needs. David is driven by passion for discovery and believes that innovation thrives on collaboration and continuous learning. As a recognized thought leader, he contributes to industry advancements through conferences, open source projects, and strategic partnerships. With over 15 years of experience, David has deep expertise in software development, cloud platforms, and designing cutting-edge systems. I think you literally really do some cutting-edge stuff. Known for mentoring fellow technical leaders, and he plays key role in fostering growth and excellence across the organization. Outside of work, David is hands-on creator, enjoying woodworking, 3D printing, CNC, and laser cutting. There you go. And David lives in a small town of Floyd, Virginia, with his wife and 4 kids. He loves making. His love of making reflects his innovative spirits, always exploring and pushing the boundaries, and that's where the fire comes in. All right, thank you very much for coming.
Thank you. I always like that bio until somebody else reads it.
It's a great bio.
And it's like, so yeah, welcome to Night of Fun, exploring a topic that I'm pretty passionate about, which is becoming a maker. And I think all of you are well suited to become one. I'm David Bates. You just said that I'm head of innovation for a company named Osmo. If you don't know who Osmo is, we do cutting edge technical support tools for the largest telcos in the world. So if you call in to say Verizon or AT&T, you have an issue with your phone, we're the tools that they use to help solve the problem. So in this role, I get to play with new technologies. I get to listen to customers and how they want to solve their challenges and steer Osmo on the right path to do so. But I'm also a maker, and I run a small shop in Floyd where I do rapid prototyping. And finally, I'm an educator or mentor, both locally and online, where I go by the name Modern Magician. And you'll see that's a theme for tonight. Modern Magician was inspired by a quote from Arthur C. Clarke, and it says, any sufficiently advanced technology is indistinguishable from magic. And so if I'm out here performing magic and other people think it's magic, then I'm a magician. So I'm a modern magician. I don't do card tricks, but I might do a shuffle from there. And I think you are too. If you check out the QR code, this has some links to some of my projects and socials, so you can connect with me. Outside of here, I'm active in the Discord for RVNUG, as well as other local community Discords and software developer stuff. Check me out. I did want to give a thanks to RVNUG for having me. I've been with .NET user groups since early in my career, and I'll talk to part of this. Even in Greensboro, we were called TriNUG. And in Greensboro, when I had lost my job at a big microchip manufacturer, the community there got me another job within a week. So love networking, and I think this is a very needed thing now, especially after COVID, trying to get people back out of their homes and in and networking and talking with other developers. So thanks for having me. So tonight we'll discuss a few topics. First off, why I became a maker. Then I'll go into my journey. And while everybody's journey is different, it'll give you a roadmap of where to dive in instead of trying to tackle everything all at once. Because you could go out and buy a laser cutter and be like, I'm on a laser cut. Why spend $1,200 when the thing I'm going to show you tonight's like $35 and you can get some enjoyment out of it. I'll go over tools of the trade, which one's buy first, And then finally, talk about the impact that it can have on you, your career, and the community. Now, a quick show of hands, how many people in the room recognize any of the symbols on the right page? Nice. How many of you know what this circuit actually does?
I'm still thinking.
Yeah, so to some of you,
Lights when there's lights.
and there's lights. To some of you, these are obvious symbols. To everybody else, that might as well be runes in a spell book. Right? So that's where the magic comes in. But it's really one of the most useful circuits you can have in your arsenal. It's called a beam brake sensor. And you run across these all the time. It's in elevators. When you stop the door from closing on you, that's a beam brake sensor that causes that to happen. When in garages, when the cat runs out from under the door and the garage door goes back up, that's a beam brake sensor that does that. If you run across an automated gate, and we have to deliver our trash to like actual trash big boxes, and there's a gated entrance to it that closes at sundown. But if you get stuck in there and the sun goes down right when you're in there, the gate will close. But there's a beam brake sensor on the inside of it that'll still let you open it and drive through. And sometimes you can even use it for 6-foot giant pumpkins to know when somebody's walking up to the pumpkin.
Nice.
So why become a maker? To me, every engineer or developer already is. You already make magic in software. One of the fundamental things that makes us tick is breaking down complex problems into logical units. That's the job, right? Makers and maker spaces often cater to the crafts, but I believe at the root of what it means to be a maker is just being curious and wanting to do stuff, learn. And so as a developer engineer, your day job solves those complex problems, and I believe that makes us look at the world differently. It makes us want to figure things out, like the beam brake sensor. How does that work? Could I build my own? If you ask yourself these questions already, you're a maker. You're just in software right now. So my goal is to try to get you to see that it's not that much of a stretch to actually put it in your hand. So everybody's different, but I'm going to tell you one particular thing that drove me to dabble in hardware. It's just something magical about the mix of software and hardware. Today, you can take an idea, and I can take an idea I have and make it real. You know, I can work on it on the computer and I can see it, I can touch it, you know, through keyboard and mouse. With VR now, you can actually go in and manipulate things, or with AR, but you can't actually hold it in your hand. With hardware, you can actually hold it in your hand. And there's something intrinsically cool about being able to hold something from your brain in your hand and see it work. And that's where the spark is, that childish light bulb that kind of goes off and you're like, holy crap, I just had this in my brain and now I got it in my hand. So just like any journey, you unlock new skills with each bump in the road. And so I'm going to go through and highlight some of those projects that kind of unlocked a new thing for me in hopes that it gives you an example path to follow. You don't have to follow my exact path. In fact, I would say, you know, don't follow my exact path. Take a different one because there were some definite bumps in the road. And I definitely have some projects I'd rather forget than show. For me, my first foray into electronics was when I was 8 or 9. I found this at a yard sale. The box was all crumpled up, but it just about had every circuit in a book that you could think of, and it was so easy to get started. It didn't even have the circuit to start off with. It said connect wire 1 to wire 8, connect wire 8 to wire 10. And so I was able to follow along with that and kind of build up circuits and build up knowledge and understand what those runes were in that first page that I showed you. Because as I got into it, it got more and more complex. And so this was a really good way to go into it. The driver behind me actually being able to use this was to annoy my sister. So I could make noisemakers. I could take over her radio station because I had a little crystal radio in it. So when she was listening to K92 down in Greensboro, I could override the radio station and play my own music on the radio. It infuriated the hell out of me. But anyway, this was a really good introduction to it. Unfortunately, there's nothing like this out there today. They don't sell these anymore. But there is something similar to this, and with microcontrollers around, it's super easy to still get into. It's just not as, you don't get the tactile springs that you can poing and put your wires in.
Glad
So-
to know I'm not the only one that, because I had one too, and I had looked for it, and I'm like, where do I find it? So I'm glad.
They went out of business with
Crazy.
Radio Shack. There's, if you want to spend the money,
I'm sure it's out there somewhere.
you can spend about $200 and get it from Germany.
Okay.
So after this, I was interested in electronics, as a kid, but software development really took over because at that time there was like VB script and stuff that you could add to websites, and it got much more of an impact from my friends and family when I made something. So of course I started getting more interested in software than hardware. This was around 18 years ago. Supposed to be playing. So this was around 18 years ago when I wanted to create a toy for my kids that they could interact with on the computer. I had heard about Arduinos, but I hadn't really dove in yet. And I bought one, and while making LEDs blink was cool, I really wanted to connect it to the software and do a custom interface. At the time, I was building interactive displays for trade shows in Flash. And so, yes, that Flash, the one that's completely dead. And it seemed fitting to just make a little police car. And so I was so excited when I got this to work. And I just had to shoot a video of it. I'm glad I did, because now I can show it to you 18 years later. And I learned a lot from this simple app of connecting the Arduino to the computer, writing custom software for it, figuring out serial communication and how to bridge it. What really unlocked this is there was firmware for the Arduino that created a serial connection over USB to the computer. And there was a language that, for lack of a better term, or protocol that it come up with called Fermata. And what it would do is if you wanted to blink an LED, you had to send a special serial command, and it would blink the LED. You had to tell it which pin and to blink and stuff like that. But it was super easy to do once you loaded the firmware on it. So that kind of got me hooked. Next up is my first professional entry into mixing electronics and software. This was for RF engineers. They made a custom racetrack with Sphero balls. If you've never seen a Sphero ball, it's just a little robot in a ball that you can control with an iPad. The gate shown in the video uses color sensors to detect which color actually hit the gate first once it was closed, and then it could actually take that color and apply it to some other software in Twilio that would text out people who had won or lost. What it was, it had a scoreboard that showed different wins. People could text to Twilio
Slipping to the car, go driving to the farthest star. I don't need to walk around in circles, walk up in circles, walk
Yeah, the cool
around
thing
in
about this
circles,
is that
walk around
it got me in the door. All of these people in this room were my coworkers. They were engineers, RF engineers who were working at a level in hardware that I couldn't even fathom at the time. But it got me in the door with them. Now they knew who I was because they knew that they put the Sphero all around, and they were like, "Man, this is really cool. How did this guy do this?" And so it not only allowed me to get paid for the creation of this, I got to play and actually build something, but at work it also accelerated my career. The next one is something you probably heard about, but you may not remember, and that's antenna gate. No, not this antenna gate.
Oh my God.
Definitely not this antenna gate, but this one.
Oh, yes.
You know the one where Apple told everybody they were holding the phone wrong.
Yep.
And so the problem with this was there was a metal band on this phone when they came out with it. Before it was ceramic, but when the iPhone 4 came out, it had a metal stainless steel band around it. And if you, with your meat bag, actually bridged the connection on it, it would change the capacitance of the antenna. And so you became the antenna, and your signal would automatically drop, right? And it was this spot right here, this little this little band that if you bridge that with your thumb, it was over. And the fix was easy. All you had to do was switch to a different antenna or break up the antennas around the phone and switch to the proper one to get the proper capacitance. The problem was, there was no switch that small that could switch fast enough to go between them, and there was nothing that automatically read capacitance. And so, as I said, from the Nerdia, when this came out, the engineers at Apple wanted their software written on Mac. And before that, all of the RF engineers were writing Windows software. So nobody at the company knew how to write Apple software except for me. And so they brought me in to write software to control the switch and actually give it to Apple test engineers. And so I was sitting at a desk with all these RF engineers with my little MacBook Air, writing software, and through an electron microscope, seeing a switch go like this. It was one of the coolest projects I've worked on.
That's awesome.
Yeah. From that, so after we wanted that fixed, so the iPhone 4S actually had my software or had used my software to fix antenna gate. After that, it kind of accelerated from there. And so they were like, hey, can you do these 3D printed trays? You know, we make these silicon wafers, and we need trays to actually ship them over here without it damaging the trays. So could you model in 3D print those? Sure, I could do that. Hey, could you have a CNC out of Delrin this part? Sure, I could do that, you know? So it just kept on going. It was definitely like drinking from a fire hose. I learned so much about like RF engineering and how chips are made and how electrons pass through different conductive material. It was pretty crazy. I called every odd job that they could give me. One more thing. The final part of this was I was probably about 6 years with RFND. They were, and my VP of marketing, I was in marketing because I was building trade show booths and running a website and stuff like that as I was doing all of these side projects. Our VP of marketing, or he was a president, he retired. And we got another president or VP, whatever it was, but he was over in California. And he was like, well, we're just going to do away with the entire marketing team in Greensboro and rehire, outsource stuff in California. And so I got laid off. And it was crazy. This is the moment that I was saying that like the community is what really got me through. It was okay because I was authoring a book at the time. You know, I was doing crazy side projects. I was speaking at the RVNUG events and Carolina Code camps and stuff like that early in the days. And so there were several of us in the community trying to outdo one another in these holiday props. And so there was 3 of us, and us 3 were kind of known in the industry. So as soon as I posted on Twitter or whatever it was at the time that I had lost my job, I had another job within a week working for Disney and Verizon at the same time. And so this is the original pumpkin tablet sitting beside of it. Custom software that I wrote as an Android app.
I want
a speaker inside the pumpkin. Kids could talk to.
I want $1,000 on my birthday.
Say, that is cheap.
You're
How
cheap.
about a wish? I can't tell you if it will come true or not.
Are you the weirdest pumpkin in the world?
As I gaze into the mist, I say,
No, now.
that's ridiculous.
There's no better stress test than having your kids play with it.
Yeah, absolutely. And this was the first firing of one of the pumpkins. So it's a lot smaller. The firing mechanism now is a lot smaller than this. But as I said, it was the original one was a late plug-in refresher that I just stuck a grill igniter to the front of it and hooked it to a microcontroller.
Wow, I'm glad you didn't bring that.
Yeah. And so this one is that inside of a pumpkin. So you can see how it actually looks. It'll fire again in a second.
That's awesome.
And then on the bottom right is the thing that actually got me my job at Disney and Verizon. And it was a small rover that you could actually control with an iPad, and it had a camera on it. And so, if, now you're probably like, well, everybody can do that. I can buy one of those off the shelf. Heck, Wisecam actually come out with one of those. But when I made this one, nobody had done it in this way. Like, you could have a controller hooked to it, but nobody had done like computer control of the little rover bots. I mean, I'm sure there were people that did, but nobody in this area.
And the fact that you did it with Windows 8, that's an extra accomplishment.
Yeah, it was Windows 8. It was all .NET. In fact, it had a NetDuino running it.
Okay.
And the pumpkin that I was showing was that had the firing thing, and it had a connect hook to it because it was part of my book, where it would use the Kinect's ability to sense humans to tell whether it was safe or not to fire the pumpkin. So in the work that I did for Disney and Verizon, we basically won contracts for ideas, and I had a ton of ideas. So, but the most notable thing that I did was probably the Magic Band. I didn't come up with the Magic Band, but I worked on the RF front end on it. Then I also won the contract to work on the assembly line for it, the injection molded parts and putting it all together.
Cool.
Then I won a contract on how to laser mark it, which is what you're seeing up here, laser mark and verify. Then I won a contract for building the robot that actually folded it up, put it in the box. And then I won a contract for the RF thing that actually scanned the box. We called it the out of box experience, or UBI, that made sure that they were put in the right place. So each of those was individual wins with Disney, but as we started winning, we'd win more and more and more. And it eventually got to where I was writing software for the parks and the cruise ships to be able to track the bands. So from the inception all the way to like when you go to the park and you tap the band on something, that's software that I wrote. And if you want to look at some real enterprise software, Disney uses Oracle for everything. This over here at the bottom left was my desk. So you can see this little red tote here. I actually didn't bring the red one, but I typically bring the red one with me. That was my little tote that is like these that had a bunch of little sensors and stuff in it. But having a robotic arm at your desk is actually pretty cool. Because you start to wonder, could I get it to pick up my coffee and actually?
And did it
have digits?
No, it had a pincher.
Oh, okay. So if somebody walked by, you could not say like, eh.
It just had a little pincher.
That way you can keep on typing and still drink coffee.
Although this was when I was developing the 3D printers too, so I could probably printed one for it.
So did you ever successfully get a drink of coffee from them? Okay.
It's spilled all over the place. It was more, if you're familiar with Simone Gertz, it was more of a shitty robot than it was a good robot. But all of this come at a cost. I was working 60 to 80 hours a week. I had 3 kids at home. My work was over 45 minutes away, so one of my kids actually in a grocery store, when somebody came up to my wife, they were like, my kid said, hey, my mom lives here, but my dad lives in Greensboro. So I was like, oof, I got to spend more time with my kids. So I was like, I'm tired. And Modea, David's earlier company from Osmo, had a slogan on their website that said, come to the mountains. And so I uprooted my entire family and we moved back to Floyd, which we had lived in Floyd prior to me going to Greensboro and trying to pursue my career. So it was almost like coming back home. And that's been pretty fun since. One of the things I didn't want to lose though, going from like all of this hardware and maddening, working for Disney and Verizon at the same time, was seeing kids interact with my creations. And seeing the pure wonder that they would have when it was seamless. Like, they would try to figure out how it would work and they couldn't, and it's just magic to them. And so I wanted to continue building those things that created those kind of experiences. And it was really how I learned things too. So when I started learning new software techniques or started learning about something in the job, I would intrinsically ask, how can I put this in a pumpkin? Could I make this work on a Christmas tree? Could I make something that actually embedded this technology in a weird way to get me to understand it. And so that was part of my process of actually understanding how to do stuff. If I can make it work in a pumpkin, I could probably make it work in an enterprise. So I continued with the holiday themes, creating, highly interactive holiday displays on the side to learn new things. IoT controlled talking and flame shooting pumpkins, trees that you could tweet at, change colors in person with paint swatch cards, or even reactive music. Stranger Things walls that you could tweet. Basically anything that you could think of to adapt something. And the technologies that I was using in these were actual technologies that Osmo was going to use at the time. And so like when Osmo needed to learn about Elasticsearch, I started asking, okay, well, how can we use Elasticsearch to store tweets and then filter through tweets and then filter that to the colors? Or when I was trying to do my flame shooting talking pumpkin, we were using, I can't quite remember the name of it. Maybe it was another IoT provider, but I was like, okay, well, how do I take it from this hardware button to store it on, something in the cloud to then have this microcontroller read it? And it was that relay that I needed to figure out, for something that we were working on at work. And it worked. Kids love the interactive trees, despite this view. This was actually my most favorite reaction to one of our trees. When Mom posted this on Twitter, saying that he's disappointed that he couldn't turn the tree black. And if you think about the lights, I didn't code in turning it off. I'm glad I didn't. But it was so cool to see that. People would line up to check them out. I was featured on different maker sites like Adafruit. And I even got to travel the country showing people how to leverage holiday projects and making as part of innovation's play process. And so just this past year, I took my 6-foot AI-powered talking pumpkin to the emerging tech conference here in Roanoke and had it set up for a week outside in a hallway at Hotel Roanoke where people could just walk up to it and talk to it. And there were so many people that would walk up to it and ask it questions that I would have never thought of. Personal questions, questions about topics I hadn't heard about, asking it just to tell a joke and hearing what it came up with. It was just very neat to experience. And I want that for you guys too. Because I'm not doing anything special. It's just over time, I've developed a way of making these things quickly. But you can do this too. And it's been quite the ride. So I could spend the whole talk talking about specific creations and how you can really change the way you approach complex problems by incorporating these challenging and fun things to make. But I promise to show you what to buy to get started. This slide contains most of the elements that you should look to get. And we'll go through each one, but we'll start with the microcontroller since they have kind of changed the game. I talked early on about that 201 project and how you can't really get that today. But I think that you might not actually want that today because it's static. There's no software connected to it, right? With a microcontroller, you basically have that 201 project, but you can wire up sensors to it and you can wire up screens and you can write software for it that interacts from your phone or your Mac or on the internet for other people to actually reach into your home and change things. It's pretty cool. So if you're not just looking to make a noisemaker, or we can start with a blinking LED or a button, and then you can start wiring that up to the internet. And I wanted to go through a couple of microcontrollers I had here. I brought a couple of them to show you like how different they are. And I'll start with the original Arduino. So this is an Arduino Uno, and it has, I think it's 20 pins, 24 pins, and a pin you can use as a control. So you can read something from it, or you can write a button for it, and so blink an LED, or send a signal out to something. So you have 20 different things that you can control from there. And it even has a little barrel jack for inputting extra power if you need to, you don't get it from USB and you need to power something more. And it comes with an IDE that's super easy to install. You just pop this in, it'll auto detect it, and you write it in C or C++ style code. It's called processing that you write code in. Then, so that's been like the reigning champion for a while. But when you need more IO, so say 20 isn't enough when you're doing industrial automation, then you go to the Arduino Mega. And so this one I think has like 50 different pins that you can do. So you got 20 on that one, 50 on this one, and it's the same kind of setup. If you write code for this board and you want it to run on this board, it's the same code, right? You just upload it to this one. So from the original Arduinos, then everything kind of exploded. People started making NetDuinos, people started making RF Duinos, Wi-Fi Duinos, all kinds of Duinos, until the ESP8266 came out. So the ESP8266 includes a Wi-Fi chip on top of an Arduino style board. This one was a 16-bit, I think it was a 16-bit processor that you had a lot of RAM on, and you could program it just like an Arduino, but then it also had MicroPython. So now you could run Python on this. Or it had JavaScript runtimes that you could run on it because it was a 16-bit board. And so it made the bar to entry much lower than what it was previously. And I've got a couple of the variants of ESP8266s up here, but then came the Linux boards. And so you had, this was the original one, it's called a BeagleBone. And so BeagleBone was a 16-bit board that was basically Linux on here. You had a Linux computer that also had Arduino kind of hardware outputs. And so you could just run the whole computer on here. And so this was really great for electronics like rovers, and it had Ethernet. So if you wanted to use it in like industrial automation, you could just connect it to Ethernet. In fact, I made one of the things around the Verizon center was we would track as shipments went down, and I had a little RGB light on top of it that was just Ethernet controlled. And so the PLC software would tell this board, hey, you need to turn the right light red because we're missing boxes or something. And so this board actually powered that. Then you have a Raspberry Pi. This has got a custom 3D printed case on it. This is what the Raspberry Pi looks like out of the box. It's got 40 pins that you can use up here, plus Ethernet, plus USB, plus HDMI. And so not only can you have a computer, that you can run in Linux, you can actually hook it up to a display that runs HDMI and have interfaces. And so I actually hooked this up to a ton of like little 8-inch touchscreens and made custom interfaces for stuff. And then this one had a little Wi-Fi dongle, and it has a custom PCB on it that we used for one of the Christmas trees. Then from there, if you're into AI, ESP32 came out. ESP32 is a 32-bit board, and I've got a couple of them sitting up here. So like this is an ESP32. It still has that same Wi-Fi chip, but it's now 32-bit, and it can run more stuff. And it has more memory, and it has a screen embedded right on it, and it has a battery monitor. Or you could get it with a camera built in that can run custom AI software on this to be like do object detection. Or you can run a larger screen. There's a touch screen, to do your own custom interface. This touch screen was for another Christmas tree that we did, and it was just mainly to be able to reset the tree and monitor the controls. Or you can go the more Raspberry Pi route. This is an NVIDIA Jetson. And so this chip on here is an NVIDIA chip that has, I think, 40 flops or teraflops of AI power built into it. So if you think about going out and buying a 4090, those are going to run really, really big, not really big, but big models. This one can run custom models that are smaller, but run it in real time. And it's basically a Linux computer. It's got HDMI, display port, USB, Ethernet, plus a camera built into it. So if you're looking for like, say the end effector of a robotic arm that you wanted to manipulate and you wanted it to be able to see, you can slap that thing up on the end of the robotic arm and have it autonomously monitor and do that and feed back over Ethernet to something else. So that's a little bit of the gamut of them. One of the final things I'll show is This is an ESP32, as small as you can get it, running Meshtastic with a temperature sensor. This sensor right here runs temperature, humidity, light, and stuff like that. And it broadcasts this over the Meshtastic network so that other people around here with Meshtastic nodes can actually see what the temperature is in this room. And so I use this at my house in various rooms in the house to actually be able to monitor the temperatures in individual rooms. All right. But the one that I would suggest that you get is an ESP32 kit. And this kit contains everything that you have on the screen. So it has those sensors, it has a keypad, it has a screen, has an RFID little tag if you want to make your own door locks, and it's $35. So you get the microcontroller, you get everything, the LEDs, the motors, all of this all in one. And it already has Wi-Fi and Bluetooth built in, so you can connect it directly to the internet or to your phone. Plus, it can support multiple IDEs and languages such as Arduino, which I mentioned, which is C++ style, or you can use Python or JavaScript, even Swift. So if you're an Apple developer and know how to write Swift, Swift will actually compile on this board through VS Code. And since it has all of these extra little bits with it, there's a book that comes with it too, just like in that 201 starter kit, that walks you through how to actually wire these sensors up and has sample projects for it. And so you can actually go through and run through the book and then do more complex things after that. So
This is all just for $35?
Yeah.
I'm looking at this, because the remote is got a fan in there. Jeez. Wow.
yeah, these are not affiliate links either. It's just truly the best deal I could find.
Wow.
I was gonna ask if there's an affiliate link just to give you a kickback, but
Yeah.
yeah.
And so this is really all you need to get started in electronics. You could buy this, hook it up to your computer, install Arduino, and have it running in an evening and be blinking LEDs, adding switches, adding a keypad, adding a screen, and you can start to learn all of these things through that. And when you see my flame shooting pumpkins, literally it's one of these things right here, which is a transistor hooked up to a grill igniter and a glade plug and a glade sprayer. So once you learn the basics of how to wire these things up, you can take it to wherever you need to. There's one more thing that I would recommend to people starting out, and it's not necessary. So as I said, you could take that $35 thing, take it home and start learning how to create hardware things yourself. But there's something about being able to print an enclosure for it, being able to print a stand for it, being able to print props that just makes it so much more magical. Because as you can see, this shows everything, right? But it's the same thing. I got to tuck the wire in. It's the same thing as that. But this looks much cooler. And I can screw a little spike on it to stick it in the ground if I wanted to. And so that's much, much cooler than just breadboard. So the link that I have up there is I think it's a $400 and some printer. It's a Bamboo Lab A1, but the link that I sent comes with the multicolor kit. I would say just starting out, just buy the printer, just without the multicolor kit, unless multicolor kind of excites you. But they're so easy to use now. I can literally start prints from my phone. In fact, I have a print going at the house, and I wanted to show that. So let me stop sharing and share. Bamboo Studio. I found it in the list of windows. So this is Bamboo Studio, and currently Newton, which is one of my bigger printers, is printing this right here for my daughter. And so Amazing Digital Circus comes out tomorrow, and this is one of the characters from the Amazing Digital Circus. It's a movie that she's wanting to go watch. And so she said, "Hey, Dad, could you print me a custom popcorn holder?" Because I printed one for my son when we
Cool.
went to go watch Mario. And so I said, "Sure, why not?" So this is it printing it right now, and I can connect to it from anywhere as soon as it buffers. It says it's initializing.
Live demo.
The
Yeah.
printer, the 3D printer has a camera, or do you have a separate camera?
Nope, comes with a camera that you can just monitor it from anywhere. If I was to do it from my phone, it would just pop right up, but I'm guessing the internet's lagging or something.
We never have problems with our internet here.
No, never.
Or is it? Don't- Yeah, I may have been in the wrong printer. But you can see there, it's saying it's failed to connect to the server. So like Bamboo is not connecting, but let me see if I can bring it up on my phone real quick. Show you. And there's an app for your phone so that if you wanted to, you could actually go through and start prints right from your phone. Like I could pick out something from Maker World. Like say I bought that ESP32 kit. I could search Maker World for it. Yeah, here it is, printing from my phone. I can see the progress on it right now. Here's the printer moving. It's past the bottom teeth now.
So for a print that size, how long is that one gonna take?
That one was 11 hours.
Can you do it again now that you stopped sharing? Because the picture is a little bit better.
Oh, okay, yeah, sure. Share your phone. There it goes.
Sweeten and lubricate the x-axis linear around.
This one's a cool one, so I wouldn't suggest getting this as your first printer, but this printer is especially cool because it's a tool changer. And so it has like six nozzles on one side that it can just swap in and out really quick to do multicolors or multi-materials. I've been 3D printing since like 2011, so. All right, let's see. Here. So I'd highly recommend getting a Bamboo Lab just because they're so easy to get started with. You can work it from your phone. The ecosystem is great, and you don't have to figure out anything. You just press print. And so you could buy that ESP32 kit, search Maker World for ESP32 kit enclosures, and there's probably a million there that you can choose from. Just like this enclosure for the Raspberry Pi. This was like in 2014, 2015. Like I just searched Raspberry Pi enclosure and printed one. And so there's the what we call the pumpkin human detector, and I showed you in person just a second ago how it looks cooler. But really, the story behind that is that I needed something that I could stick in the ground because I was actually showing this off in the middle of town in Floyd. And so I needed something that I could stick in the ground and use the beam brake sensor along a walkway for people walking up to the pumpkin so that the pumpkin could know when people come up. So it didn't, I didn't have to press a button or anything. It just knew when people would walk up and go, "Why are you disturbing my snow?" And so having this 3D print with the spike on the bottom was necessary in order to do that. And I was able to also print a laser pointer holder so that I could point a laser at it on the other side. And it's got the same cutout to be able to put a spike on. And so I designed that, but you don't have to design your own prints to start off with. You can just go on Maker World, find something, and download it.
So for that, how did you power it?
With a LiPo battery.
Okay.
One of these.
Nice.
How long did that last about?
Well, for the laser cutter or for the laser pointer, forever.
Yeah.
Like this thing hardly uses no power.
Yeah,
There's
that's
a little-
pretty hefty battery. So, yeah.
I won't point it at anybody's eye, but you can kind of see the red dot there. And
Across
then
the street,
this was,
somebody's going like, "What the hell is that?"
this microcontroller I powered off of a smaller battery pack, like a 10,000 milliamp hour battery pack with a USB,
Okay.
cable.
Sure.
So what is that device then? Is that the beam,
This
the
is the
beam sensor?
Yeah, this is the beam, and this is the beam sensor inside of this hole. It's a PI, it's not a PIR. It's basically a solar cell. And the solar cell, whenever it gets light, emits a certain amount of energy. And then it's hooked up to an analog pin on here that just detects how much energy that solar cell is giving off. And so I monitor this on here, and this connects to Bluetooth Low Energy to the Mac or to my phone, and will actually broadcast an alert when that energy goes too low through a certain threshold. And I'll actually show that here in a few minutes. Maybe sooner than later. I want it now. So yeah, from here, the sky's the limit. You know, I could give you specifics for what you were interested in if I knew what each one of you were interested in, but as a whole, everybody's interested in different things. These are some of the tools that I utilize over and over and over again in projects. So I use a laser cutter and a CNC machine, which is basically the same thing, just the head on it's different. 3D scanner, I use a bunch of woodworking tools. You would be amazed how many woodworking tools and techniques that you can use in plastics and paper craft and fiberglass. Woodworking tools is a great thing to do. And some leather tools. So like rivets and the things that you use to ream around plastics to just do small cuts, those are invaluable. But I'd also recommend multimeters. You know, having a good multimeter as a handy person around the house, just to be able to say, oh yeah, this outlet has power, or oh yeah, this is 12 volts, is essential. And then also things to measure with. And so micrometers is and you can get a digital micrometer fairly cheap, like within 15, 20 bucks now. But if you're trying to like measure this board and say, in CAD, I need to draw this out like 60 millimeters, you need to know that 60 millimeters is what it is in the real world, and that digital micrometer will let you do that. I would also say, don't go out and buy leather, or don't go out and buy any of these things. Use our local makerspaces. You have access to Roanoke's makerspace here, and there's also one in Blacksburg called Hacksburg, and they have CNC machines, and they have laser cutters, and they have 3D printers, and they have micrometers, and they have leatherworking tools, and they have woodworking tools, and they have people that know how to use them. So
Important, yes.
yeah, that's the important part is you don't have to figure out or watch a YouTube video on how to do it. You can be like, hey, I've got an idea. I need to go make this thing, and have other people that be like, ooh, that's a cool idea. Let me show you how to make this thing. And so we're really lucky to have two of those nearby. That was one of the things I missed coming back up here from Greensboro is Roanoke didn't really have a makerspace. Blacksburg did, which is cool, but I was more in Roanoke when I first moved back up here. So yeah, I'm glad that we have them now.
And they're really active. They have meetings 2-3 times a week about different things.
Yeah. They have classes on how to use the tools too. So final slide is the impact. And so I think it already played there's the animation for you. Bit of a static one. And so the impact that you can have is just like me. When other people around me found out that I was a maker, they started talking to me about making things, right? Their ideas that they wanted to make. When you show somebody something that's magical, they'll keep coming back to you, almost like a drug, wanting that magic again. So it not only will have an impact on your career because you'll understand software and technology at a lower level than you do today. Like you actually learn about serial communication or Bluetooth Low Energy or Wi-Fi packets or the certificates, because one of the downfalls of some of the earlier Wi-Fi enabled microcontrollers is they couldn't do SSL because there wasn't enough memory on them in order to hold a certificate. And so when OpenSSL 2 came out, it was like, holy crap, this will never work again. So you understand why those things are the way they are, and that there is an actual certificate file that needs to live on there in some kind of encryption method that needs to encrypt the packet. And so you'll learn these things at a lower level as you get into them. And it's just really cool. Plus, if you do this for a while, you get to go out in the community and tell other people about the cool stuff that you get to build. So highly recommend trying to become a maker. Finally, we'll do a little demo. And the demo is what I was talking about earlier about I'll get into how some of these work.
This is where we have to have the fire extinguisher ready, right?
That's right.
Okay.
That's right. All right, so the first thing I want to share is Arduino. And I think it's probably best if I just share my entire screen because I'll be bouncing back and forth between stuff. So I showed you Bamboo Studio, which controls my printer and is made for 3D printing stuff. This is the Arduino IDE. So as you can see, it looks like a code editor. It talks like a code editor. There's a file system on here. There's a terminal, and then a serial kind of.
Can you like zoom in, or it's hard to see any
read.
of the print?
See if I can't do that.
Have to change your color scheme.
Yeah,
It's actually pretty slim on the screen, so the YouTube video will show it correctly.
I was trying to see. I actually don't know how to do that.
Screen
Oh,
over.
Yeah, you know, it's fine.
Editor font size also. Right above it.
We'll increase that. Go to font size. There we go.
That's good.
So I did high contrast and increased font size.
Bunch of old people here.
I know. Thanks, Mike. I needed to hear that today.
Right now I have, this is called an Arduino Maker WAN. It's one of their newer boards that has Wi-Fi and everything built into it, but it's a really cheap board, right? I think this one was like $50. And it came with a bunch of stuff, and it can connect to the internet, and it has a battery post on it. But what I wanted to show you is this blinking LED here is from code that I've written. Right? And so code for this to start out with, when you open the board and you get it, it's just wanting you to blink this little onboard LED. So there's a little yellow LED there. And so you can see here, I'm setting up a pin mode for the built-in LED to output, right? And there's two parts to this. There's setup and there's a loop. So in setup, you're basically defining everything that you're trying to get going. And then in the loop in a microcontroller just runs over and over and over and over again. So this is where you want to read your sensors, set your outputs, do any kind of state management that you need to do. So setup is just get everything going, define all of your things, and then the loop is just over and over and over again.
Well, keep on talking about this. I just wanted to make sure you saw my hand for a question.
Yeah.
But after you've talked about this.
Is this C?
Yeah, it's actually processing
C-ish.
or wiring, which is C-ish, so it's C++-ish. Okay, so this is the out-of-the-box sketch. And the out-of-the-box sketch will blink this little LED on the board, but not this LED. And so I had to modify this in order to blink the other LED. I don't know why it's doing that. It blinked out on me.
That's cool.
But it's easy enough to edit. So there's a blank sketch. So if you see, I went to File and Sketchbook and then Examples, and there's a bunch of built-in examples. And I'll show you one of the ESP32s below, and you'll see there's a bunch of examples for it too. But in this one, just the basics, blink. We're blinking the onboard LED. But what if I wanted to change that to this LED? It's super easy to do. You define an int. So up here, we're going to define, well, we're just going to say int, and then we're going to say LED pin. Okay? And then I'm going to set that to 6 because I've actually got it wired up to the 6th pin on this board, and there's little numbers on the side of this thing, so they make it really easy so you can see which number it is. And so LED pin equals 6, and then all I got to do is copy this, right? This in there, copy and paste it, and then I'm going to select the right board, and I'm going to upload it. And so now it's uploading, and you can see my LED is no longer blinking as good.
Actually, we can't.
Can't see it. You can barely see it on there, right?
Okay.
See it turn red, right?
Yeah.
So now the LED is blinking. And the way it's blinking is I've told it, hey, the LED pin's number 6. It's an output, not an input. And I want it to write the pin high, and that means set the voltage on the pin, right? And then I want to delay 1,000, which is in milliseconds. And then I want to set the pin low. And then I want to wait another 1,000 and go again. So if I wanted to, I could actually set this to 500 or 5,000, 5,000. So this should turn it on for 5 seconds and then off for 5 seconds.
It's also interesting to see when you were uploading it, it was
Yeah,
blinking like it's.
that's because it's on one of the transit lines.
Gotcha.
So when it's transmitting over serial, it was actually activating that pin. Anyway, on for 5 seconds and then off for 5 seconds. You can see it's on for much longer now. And I could change that too. I could say I want it on for 5 seconds and off for 1 second. So you can start to see how you can manipulate this to do whatever you want.
Some of the pins analog and some digital.
Yeah, some are analog and some's digital, and just about to do that. So the next thing is fade. So one cool hack about our eyes is that if you can blink something, if you can send a signal out, actually it's not just our eyes, but if you can blink something really, really, really fast, you can actually make it look duller or brighter. And so there's this fade function here. And so I got to set the LED pin to 6 because I've got it wired up to 6, and how much fade I want. And you can see right now it's just on and off, right? 5 seconds on, 1 second off is what we programmed it to do. But if I do this, now it'll fade in and fade out. That's just fading in and fading out. So if you can see it better in person that way.
Yeah.
That's using a trick called PWM, or pulse width modulation. And so it's just blinking it really fast in order to turn it on and off really fast to get that effect of making it brighter or not as bright.
Isn't that how the light bulbs you even buy for your bathroom and whatnot, the dimmable ones
Yeah.
do it?
That's exactly how they do it too.
Or your PC fans.
All right, so one more.
I'll ask my question now.
How fast they move.
So how has writing for embedded, Arduinos, et cetera, has that changed how you look at writing software on other platforms?
Absolutely. Because you want to decouple it. So you already in software want to decouple your priorities, right? When you're running on limited resources at the edge, you have to really think about what does that mechanic between the software and hardware look like? Because I don't want this thing parsing 1 million lines of JSON. I want another computer doing that. So I want this thing to get whatever sensor readings it needs and just dump that off to the bigger computer. So you have to really think about how to architect systems when you're dealing with lower compute modules.
How much memory do you have?
I'm not sure. Each one's different. The ESP32s, I think they have 8 megabyte of memory, something like that. You can get an ESP32 CAM that has gigabytes. And then you can also, so these Raspberry Pis, you can actually get ones where you can put a hard drive on it. It just depends on which one you're using.
I think the biggest port there, 8 gig of RAM.
Yes. 8 gig of RAM, but then you can have unlimited storage. And some of the Broadcom chips on the Raspberry Pis can actually do a lot of processing. So you might want it to actually process that JSON, locally, so that you don't have to offload that onto a server, especially if you're deploying 1 million of these across a warehouse. But process that and send the final results back.
Air gap networks or whatever.
So the last thing I'll show is the pumpkin, the human, the pumpkin human detector. For the PhD. So this one, it's a 3D printed case, and it has a screen on it. So there's a little pumpkin down here. Actually, let me see if I can show it on that. And it says that it's waiting for a connection, right? This runs Bluetooth Low Energy rather than Wi-Fi, even though this chip is Wi-Fi capable. And so I have a Bluetooth scanner here, and if I go back and scan, you can see all kinds of Bluetooth Low Energy modules around us. But there's the Pumpkin King human detector, and if I connect to it here, you should see that it's connected, and it's going to say person found, right? Or yeah, right now it's saying no person. There we go, person detected. That's what it's saying. And I guess it's so bright in here because I'd normally deploy this in like dark. But if I turn it up towards the light, it'll say no person detected. And so I can debug it right here on this screen. Now the code for this is actually pretty straightforward, although it looks weird because there's a lot of Bluetooth Low Energy stuff for configuring it. So I have a service UUID, a characteristic UUID, different things set up for checking stuff, some classes. But if you can see, there's still just a setup function. And then down here, there's a loop function. And so the setup function is setting up like the serial port on here to talk back to the computer for debugging. It's setting up that display and the fonts that I'm going to use. It's setting up the initial message that I'm going to display on it of like waiting for a client to connect. And you can see that here. And then loop, whenever it goes through, it's going to do an analog read. So as we said, there's digital and analog pins. Digital is like on, off, 5 volts, 0 volts, 3.3 volts, 0 volts, a square wave. Whereas an analog can detect a sine wave. So it can detect any range in between 5 and 0. And so when you want to use an analog is when you're detecting like finding power. So I want to know exactly how much power this little sensor is putting out. And so all the loop's doing is it's going through and checking this analog sensor pin on that solar panel, which it's not a solar panel, but it's very similar to one, and seeing how much energy it's actually outputting. And if it goes above a certain threshold, it'll say person detected. And if not, it'll say no person. That's it. And it updates the display and it notifies the Bluetooth Low Energy. So it's not a very big, program, but it's packing a lot of, it seems really cool. And there's also a serial monitor, as I said, that it connects to. And so I can see the actual value, the voltage value, 3.7 volts that it's outputting right now. And then every so often it's saying, hey, there's no person because there's a light shining right on it. But if I cover this up, that says person detected. And so it'll send that over Bluetooth Low Energy in order to trigger the pumpkin. And so when it sees that no person detected and then a person detected means somebody walked through the beam brake sensor. And so now the pumpkin app knows, hey, somebody walked through, let's scare the crap out of them. Right? And so that's this one.
You said it uses a solar panel in there?
It's like a solar panel. It's a LD
Light sensitive diode?
light sensitive diode. Thank
Okay.
you. Yes. So you'll see it's brown and it has little waves in
Yeah.
it rather than being black. An LDR is what it's called, I think.
Okay.
Yeah. Light. That'd be cool. But anyway, the more light you get, the more or the less resistance it has, which means more power runs through it.
Yeah, I was thinking if you get the solar panel in there, it actually can generate some of its own energy.
The final thing I wanted to show is the Meshtastic. So this is Meshtastic. It's an app that you can have on your Mac, on your phone, or whatever. We talked about this a little before, and I think I showed the microcontroller. But all this does is lets you communicate over a mesh network. So there's a 400 to 700 megahertz antenna in there In fact, it's this little antenna sticking out right there. And so there's a little antenna on there that can communicate and it connects with other mesh nodes that are running the same firmware. So this is really a lot of different people going, hey, if you put this firmware on your thing, we could talk together, right? And so there's a mesh map, and I don't know if we've picked up anybody else. It doesn't look like. But when I've been out and about before, it can pick up other mesh nodes around, and we can just communicate with each other.
We're right next to a retirement home, so.
Oh yeah, there's some more nodes. Oh yeah. So these are nodes that are around us. This one, this HBA1 is my home node, like my main home node. This Meshtastic D8BB is this one here. And then there's something Entropy Collector and WSLS Studio. But anyway, a couple of cool things that this can do is it'll broadcast the current environment. So there's a temperature and humidity and pressure sensor hooked up to this Meshtastic node. And so I'm broadcasting every few minutes that is whatever the temperature is, whatever the humidity is, whatever the pressure is. And I also get a log of it. And so I can see what the temperature has been in here since we've been in here. And this is broadcast, like when I'm at home, this actually broadcasts all of my other mesh nodes and then to a central one because I don't want to run Wi-Fi in all of the places that I'm sensing things. And then it runs it to a central node, and that node connects to Wi-Fi and gives it to my home assistant server. Yeah.
When you broadcast, like, are you broadcasting? How does it know to format it like that? I mean, because you can broadcast, I'm guessing, anything, right?
You could, but it's an agreed upon firmware. So Meshtastic has a thing for environmental sensors, and there's certain environmental sensors that you have to buy, and they show you how to wire them up. So this is like an ecosystem that you can buy into if you want to like text with your buddies down the street without having to use a cell phone, or you want to broadcast your temperature across a farm. You can deploy Meshtastic nodes across there and have them talk to each other.
So it knows it's a weather sensor, so it knows to read. What is WSLS channel 10 apparently broadcast?
So they're not broadcasting any logs. They're just responding. So they're just doing a hey, I'm here.
So there's also relay information over that network then, so.
Yeah. So if I broadcast something, and there's another node near the WSLS node, it'll use the WSLS node to give it to the next one. That's part of the mesh network. They call it LoRaWAN.
Okay.
But yeah, so it's just another neat way that you can get into hardware because you can get you one of these ESP32s, download the Meshtastic firmware on it, start talking to your buddies, without using cellular. Like if you're out and about in an area that doesn't have cellular networking, you can still text message each other back and forth, add one of these sensors to it, stuff like that. So just another neat way to get into it.
How far do the Meshtastic antennas reach, or?
It depends. So like the one for WSLS, you can see they've got I forget what this is called, a Heltec? Yeah, Heltec. So their antenna is a lot bigger and beefier than mine, and it's got more power on the RF output, whereas mine's just this little flimsy, piece of ribbon here. And so I can get 2 miles with this. Well, not 2 miles, 1.5 miles.
Still.
2 kilometers.
Just with that, oh my God. Wow. Can you imagine if you have a really big antenna?
All right, so I'll leave it there. Showed you how to get into it, why I got into it, how my career went, and how it helped my career, and how I actually look at problems today. And so I encourage you to buy that $35 kit if it interested you. Blink some LEDs, make a little touchpad input, and then follow along. I'll be interested to see what you make.
Very cool. Thank you.
Yeah, really amazing. For $35, you can get all of that. That's just the same, including a keypad. And notice the example shows like
And a
you make
screen.
yourself a security door. As one of the exampons.
I only saw that there was a little speaker in there too. So with that delay, that little beep that comes up every 5 minutes. Noise run. Yeah.
I want to, like, if you put in the wrong password, put a really obnoxious sounds and
Very cool. Oh, I thought you were gonna electrocute people.
oh, or use one of the spray things.
Oh, yeah.
On that, what
Or spraying.
exactly are you spraying? Is it the Glade?
It's the
Which
Glade stuff.
smell are you broadcasting?
So that's another talk, but if you disperse any material enough, you can catch it on fire, it'll explode.
So you're actually using Glade, like,
Using the Glade spray and just sparking across it.
never gonna look at those Glade sprays the same way.
You can actually take flour and throw it up in the
Oh,
air
yeah,
with
flour.
a lighter and it'll explode.
Yeah.
Oh, wow.
But this was another version of that kit, but this was more of the 201. Y'all can come up and look at it. But this one uses little jumper cables, so you don't even have to worry about how to wire it up. You just plug a jumper cable in here and then a jumper cable in there, and it comes with all the software and everything. And it comes in a little box too, even has the USB cable on it. So there's a lot of different versions of that kit if that $35 one doesn't do what you want.
All right, well, thank you again. We are going to have a copy and code on the 20th. Is that right, Sean?
Yeah.
20th of June. And so come check that out. We don't have a July, but we are going to have an August meetup. So check that out. And we are right after this going to not McAdoo's, but Macamots. So feel free to come and hang out with us there. Thanks, everybody.
Thank you.
David.